All right, sixth graders, we are taking a page of notes today, and this is actually our last topic for our fractions unit. So if you think back to what we have already learned, so we will be taking a unit test on fractions here soon. The first thing in this unit that we took notes on was adding and subtracting fractions with like denominators. Then we added and subtracted fractions with unlike denominators. Since then, we have multiplied fractions by whole numbers, we have multiplied fractions by fractions, and we have multiplied mixed numbers. And that was what we practiced and finished out last week. So the only thing left for us to do, since we have added, subtracted, and multiplied, the last thing we have to do this week is to divide. We're going to be dividing fractions and we're going to look at first a couple of models. And so we're going to look at what are we thinking about when we're dividing fractions, and then we're actually going to look at a shortcut to do this faster. So let's think about what it would look like to divide fractions. So the first thing we're going to look at is, well, what does a problem like this mean? So let's look at a whole number divided by a fraction. So 3 divided by 3/4. What we're really asking ourselves here is we're asking ourselves, how many 3/4 are there in 3 wholes? So how many 3/4 are there in 3? And so if I wanted to draw a little tiny picture to represent this, I could draw 3 wholes. So here's 1, 2, 3. I could cut them up into fourths. Fourths would be 3 lines, 1, 2, 3. And I want to know how many 3/4 are there in 3. Now, when we did fractions, we shaded. For division, now we're not going to do any shading, but we're actually going to count groups of 3/4. So if you'll look, if I count my pieces here, 1, 2, 3, there are 3/4. And what I'm going to do is I'm just going to kind of draw a bracket around them. So this fourth, and this fourth all are one group of 3/4. And then what I'm going to do is I'm going to count another group of 3/4. Well, here's one piece, that's 1/4, 2/4, 3/4. So I'm actually going to have to go from this piece all the way over to get 3 total. So, and again, maybe you even put a dot next to them, like they mark them. There's a group, there's 3/4, 1, 2, 3, there's 3 more, that's my second group. And we're just counting up 1, 2, 3. So there's 3 pieces, that's 3/4, that's a third group, 1, 2, 3, and that's another group. And so the answer to how many 3/4 are there inside of 3 holes, here's my 3 holes, here's a group of 3/4, another group, another group, another group. There are 4 groups of 3/4 inside of 4, and so my answer is 4. Now that's one way of doing it with a picture, and so of course we would like to be able to do this a little quicker. We're going to do one more with a picture, and then we're going to talk about where you can actually see the shortcut happening here. So let's look at what would it look like to do 6 divided by 2/3. And so again, we're going to start with a whole and we're going to divide it by a fraction. So this is actually asking how many 2/3 are there in 6? And so what we would have to do is we would have to draw out 6 boxes. So 1, 2, 3, 4, 5, and 6. I'm going to cut them into thirds. So thirds, 1, 2 lines, thirds, 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 and thirds. And then I'm going to group them to see how many 2/3 are there actually in 6. So I'm just going to count groups of 2/3. There's a third, there's a third. That's 2/3. There's one group. There's a third, there's a third. That's another group of 2/3. Here's 2 more thirds. So there's 3. 2 more thirds, that's 4. 2 more thirds, that's 5. 2 more thirds, that's 6. 2 more thirds, that's 7. 1, 2. 2 more thirds, that's 8. 2 more thirds, that is 9. Now, we're doing some pictures here that actually come out to be nice and even numbers. We're not always going to come out with an even number. Sometimes you'll have a fraction here. But I do want to just look at what is the pattern happening here, and how could we get from 3 3/4 and 6 2/3 to the answer without having to draw this picture. And so here's what I want you to look at. Let's start with the 3 3/4. So the shortcut, actually let's label this as just the shortcut. So the shortcut instead of drawing pictures, and let's start back with the 3 divided by 3/4. All right, and so we want to look at how are these numbers related to each other, and even we could let's go ahead and look at both of them. Here's the two problems that we did. How is 3 divided by 3/4 related to the number 4? Well, we actually already see the number 4 here, right? It's really clear if we look at the 6 2/3, because where did this 9 come from? Well, how could I use these numbers to help me get 9? And maybe if you're really good at investigating math problems, you might have noticed that if you did 6 times 3, which is the denominator, you would actually get 18, and 18 divided by 2 would give you 9. Now notice that same thing works here. If I do 3 wholes times 4, I get 12. And if I divide that by 3 again, I get back to 4. And so it's a very roundabout way of saying this. The shortcut for dividing fractions is actually what we refer to as keep, switch, and flip. These are the steps for solving a division problem. So here's what we're going to do. We're actually going to keep the first number. We're going to keep the 3. We're going to switch the division to a multiplication symbol, which is good because we know how to do multiplication by fractions. That's what we worked on last week, the past 2 weeks. And then once we have kept the first number, switched the sign from division to multiplication, what we're actually going to do is we're going to flip this second fraction, the second number on its head. So we're actually going to flip it to 4/3. This is what we refer to as the reciprocal. reciprocal. And reciprocal is just a fancy way of saying flip. It's just taking a fraction and flipping it. So 3/4 flips to 4/3. If we go ahead and down here and do the next one, we would keep the first number, switch the division to a multiplication sign, and then we're going to flip that second fraction. What do you think the reciprocal of 2/3 would be? Just flip it. Reciprocal of 2/3 is 3/2. And so now we're actually ready to just do a multiplication problem, which is what we were doing last week. So anytime we see a whole number, remember we put it over 1. So this is actually going to become 3/1 times 4/3. And if you notice, what I was saying a minute ago happens. So we actually end up doing 3 times 4, which is 12, over 1 times 3, which is 3. And 12 divided by 3 is top heavy, but 12 divided by 3 evenly divides as 4. And that's the same answer we got up here at the picture. Same thing happens here. We would put the whole number over 1. So we got 6/1 times 3/2. And I'm going to multiply across the top. 6 times 3, as I said a minute ago, is 18/2. And of course we know 18/2 is top heavy. 18 divided by 2 does come out to be 9. And so we get the same answers as we did before. So the key to dividing fractions is right here. Here's your rule. And we're going to do this on every single type of division problem. All right, so keep in mind that the whole number goes over 1 if you do have a whole number. And also, we're going to do a couple here in a second with some mixed numbers. We're still going to be changing mixed numbers into improper fractions. So let's get into a couple of examples. We're going to do 4 down here at the bottom of just different types. So draw you like a fourth, split the rest of your paper into fourths, so we'll have enough room to do some examples. So let's look at what it would look like to have, these were whole numbers, we did whole numbers times fractions. Of course, let's try a fraction divided by a fraction. So let's do 2/3 divided by 4/5. Now, I like to write, a short way of saying this is KSF, keep, switch, flip. So one way I like to remember is when I see that division bar, I'm automatically going to write those letters above my division problem to help me remember what I'm supposed to be doing. So of course, we're going to keep, again, the first number. So the first fraction does not change. 2 over 3. And then I'm going to switch the division sign to multiplication. And then I'm going to flip the second fraction. So 4 over 5 flips to 5 over 4. And then I'm just doing a multiplication problem like normal. So 2 times 5 is 10 over 3 times 4 is 12. And then just like always, just like we have been doing for the past week, if you can simplify it, go ahead and simplify it. If you can change it into a mixed number, do that. So 10 and 12 are both even numbers. They will both simplify by 2. And so 10 divided by 2 is 5, and 12 divided by 2 is 6. So my final answer here is 5, 6. Keep, switch, flip. All right, let's try an example where we have a fraction divided by a whole number. So up here, we were doing whole numbers divided by fractions. Here, we're going to do a fraction divided by a whole number. So again, when I see that division symbol, I automatically am going to write down these 3 letters, KSF, just right above the problem. It will help me remember what I'm supposed to be doing. Keep. Now, a lot of people, one common mistake when you're doing this is sometimes you want to flip the first fraction. First fraction never flips. We keep it. Bring it straight down. 8/10. Switch the division to what? Multiplication. Now, we're going to have to flip this 2. Now, 2, I mean, if you flipped it, you might write it upside down. I don't know. But remember, anytime we see a whole number, what do we put it over? We put our whole number over 1. And if a whole number is over 1, when I flip it, it's actually going to come 1 over that number. So just for example, and we'll do another one here off to the side. If I wanted to flip the number 5, I would have to think of 5 over 1, and then it would flip to 1 over 5. So when you flip a whole number, the 1 goes to the top. So that's what happens when I flip 2. It's going to become 1/2. All right, now I'm ready to multiply. So across the top, 8 times 1 gives me 8. 10 times 2 gives me 20. And of course, 8/20ths can simplify. 8 and 20, they are both even, so they will divide by 2, but you can actually also divide them both by 4. You could divide them by 2 twice. 8 divided by 4 gives me 2, and 20 divided by 4 gives me 5. And so my final answer is 2/5. Again, key here being keep, switch, flip. All right, let's try a couple with some mixed numbers. And now that we have done multiplication with mixed numbers, we can do division with mixed numbers. So I'm going to try 3 2/5 divided by 3/4. So just like we talked about last week, anytime you see a mixed number, you want to change it into an improper fraction. So that is still the first, but even before I do keep, switch, flip, even before I do KSF, I want to change any mixed number that I see into an improper fraction. So we're going to do that as our very first step, the multiply and add method. 5 times 3 gives me 15. And across the top, 15 plus 2 gives me 17. Keep the denominator. So we get 17 over 5. Divided by, now we haven't done any switching and flipping yet, so we're just going to change that. Our goal right now is to just change the mixed number, division, and then we're dividing by 3/4. Now I have 2 fractions that I can actually divide, and so now once I have changed my mixed number, now I'm going to do keep, switch, flip. So keep the 17 over 5, switch the division to multiplication, and we're going to flip 3/4 into 4/3. Now, I don't know about you, but I do not know my 17 times tables. I do know that on the bottom here, we're going to get 15, but 17 times 4 is something I don't have memorized, so I may have to go off to the side and do a little bit of multiplication. 7 times 4 gives me 28, carry the 2. 1 times 4 gives me 4, plus 2 is 6. So the top number here is actually going to be 68. That might simplify, but first and foremost, that's top heavy, so I'm going to have to do some division. And so I'm going to do 68. You can put 68 in the inside of the division. 15 is going to go on the outside. We have to think about our 15s. And so if you think about 15 plus 15, that gives you 30, plus 15 more gives you 45, plus 15 more gives you 60, and that's really close to 68. So 15 actually goes in 1, 2, 3, 4 times, because 4 times 15 is 60, and subtract away 8. So as a mixed number, I get 4 whole times with 8 15ths left over, and 8 will only divide by 2 and 4, neither of which will divide 15, so I know that I'm finished. So the biggest difference here between these two, we're still using keep, switch, flip. Again, you're always going to write that KSF with any division problem, but we had to change a mixed number into an improper fraction. So we're going to do one more example, and we're going to divide 2 mixed numbers here. And so again, just like last week, anytime you see a mixed number, before you do anything else, we've got to change these into improper fractions. So that is what we're going to do first, only in this case, we're going to change them both. So multiply and add for both, go ahead and fill that in. So 2 times 4 gives me 8. 8 plus 1 on the top gives me 9. Going to keep the 2 on the bottom there. Now, it's still a division problem. All we're doing right now, we're not keeping, switching, flipping anything. We're just changing mixed numbers into improper fractions. We're going to do the same thing over here. 3 times 3, denominator times the whole number, gives me 9. 9 plus 2 on the top is 11 over 3. Now that we have changed these mixed numbers into improper fractions, now we can KSF. Now we can keep, switch, flip. So I'm going to keep the first number. The 9/2 is going to stay. Switch my division to multiplication, and I'm going to flip 11 over 3 into 3 over 11. Now I'm ready to multiply across the top. 9 times 3 gives me 27. On the bottom, I get 2 times 11, which is 22. That, of course, is top heavy. I'm going to divide 27 by 22. Those are pretty close together, and actually 22 will only go into 27 one whole time, because that's 22, and you only have 5 left over. So my final answer is 1 and 5 22nds. All right, so moral of the story, when you're dividing fractions and as you're practicing this, keep, switch, flip is the key. Don't forget about putting whole numbers over 1, and if you have a whole number and you have to flip it, it's going to be 1 over that number. Also, anytime you encounter improper fractions, anytime you encounter mixed numbers, you want to change them into improper fractions. So make sure you have those examples written down so you can look back at them while you're practicing, and please send me an email if you have any questions about this topic.